In this section, we're going to go over 45, 45, 90 triangles, which we explored yesterday in that Desmos activity. And we're going to kind of elaborate on like the pattern that you guys saw yesterday. So if you remember, before we even started the Desmos activity, I kind of went over how you were going to be looking for a pattern. Your whole goal was to try to figure out what is this pattern that's maybe happening with our triangle in order to maybe make finding the missing sides easier. And we talked about how a 45, 45, 90 triangle is technically a right isosceles triangle. Remind me really quick, what does isosceles mean again? Good, it means there's two congruent sides and there's also two congruent angles, which we know because if we saw 45, 45, we know that two angles are both the same there. And then those would be your base angles on that triangle. And then we've talked in the past about how across from the base angles would be those congruent sides. Okay. All right. So when you guys did this yesterday, you had to find a pattern, right? And we used Pythagorean's theorem to help us do that. So let's just take a look at these up here just to kind of establish what you guys would have found yesterday. So on this first one, what would you be putting in for your A and your B? Good, the tens, so it'd be 10 squared plus 10 squared equals the x squared, okay? And what's 10 squared? 100, so you have 100 plus 100, which is 200. And if you broke this down, so if you simplified the square root here, because it's not going to come out nice, what would you get? You get 10 square root of 2, right? Okay. So 10 square root of 2 is our x. That's this side here. All right. Now, if we do the same thing on the second one, you could have set it up the same way, like 6 squared plus 6 squared equals x squared, right? Okay. But when you guys did this yesterday, maybe some of you noticed there was a pattern. Like, even looking over here, there was 10 centimeters, 10 centimeters, 10 square root of 2. Does anyone have an idea what my x is going to come out to be here? Okay, 6 square root of 2. And why do you say that? Okay, so because the two legs are the same, 6 and 6, you notice that the hypotenuse is that same number, but they always attach the square root of 2, right? Okay, so that was kind of that pattern that we saw happen yesterday. Now, what would this answer be over here then for the x? Right, it'd be 2 square root of 2, right? Because the two legs were both 2, and then you just attach a square root of 2. All right. Now, if you go about this the long way and you do your a squared plus b squared equals c squared, you're still going to get to those same numbers. Okay. So nothing about that is going to change at all. But so when we saw this happening yesterday, recognizing that pattern helps us figure out what those things are faster. So instead of having to do the Pythagorean theorem over and over and over again, if we see that we have a 45, 45, 90 triangle, we can maybe shortcut our way to getting an answer, right? So I want to kind of summarize down here on this picture what this looks like. So a couple things that we saw, or like the how we got to our pattern, is that we noticed our hypotenuse side was always whatever your leg length with the square root of 2 attached to it. Okay, you could also think, like if your hypotenuse, even if I maybe switch this, let's say I put an equal sign in here. The hypotenuse is equal to the leg times the square root of 2. What would be a leg length? Like if you were given the hypotenuse, how could you find just a leg? How would you get leg up there, like that word? How would you get rid of the square root of 2? So it'd be hypotenuse, I'm going to abbreviate that, over the square root of 2, right? Yeah, there's always going to be that connection between the legs and the hypotenuse on a 45, 45, 90 triangle. Okay, and the other thing that we saw on all of these is that our legs are always congruent. Okay, so over here, if my right angle is there, your legs would be this side and this side. So I'm going to go ahead and give those each like a dash just to show that they'd be the same. And then if I don't have anything labeled and I was just trying to figure out how would I maybe explain to somebody what the pattern is, I don't necessarily want to put numbers on here, right? I would want to maybe put letters or something to represent, any number could be put in here and this pattern's going to work. Now I'm going to advise that we don't use X's just because when you guys work on problems, there's going to be X's that show up in your problems. And so you want to make sure that you maybe use a different letters. Otherwise, you're going to get confused if you have like a whole bunch of X's flying around. Okay. So what I like to use instead is S. So I'm going to put S on the legs because those would both be the same. And then over here on the hypotenuse, I'm going to write S with my square root of 2. Okay. S maybe just represents the side. So the two sides or the two legs are the same. And then the hypotenuse is whatever your side length is with the radical 2 attached. So going forward now, we're going to do some examples down below, and we're going to use these side lengths to kind of help us. So anytime that I do these, I'm going to label with all those S's first, and then use what they're giving me in order to help me find the missing pieces. Okay, so let's take a look at this first example down here. I'm going to put an S on the two legs, which would be these sides that are labeled with an X, and then this is going to be my S square root of 2 side, my hypotenuse. Okay, talk to me about what you're thinking here. How would you figure out how much X is? Okay, tell me how you got to just 8. Okay, so I'm going to rewrite this. I'm going to put that S square root of 2 next to it to kind of show what you were just telling me there. So if I set them equal to each other like this, you were saying that to get the S, you would have to get rid of that square root of 2, right? That's what we kind of talked about up above with our pattern. We're trying to find a leg, so we have to divide by the square root of 2. So if I divide by the square root of 2 on both sides, what did you say happens there? They cancel on both sides, right? And so you're left with S equals 8. Good. So this side is 8, and this side would be 8. Perfect. Now, some of you maybe notice that just because of the pattern. I don't necessarily need to see all that work all the time, especially if you start to see, I think like something like that, or even like the second one, those are probably the easiest case scenario where you maybe don't need to do all the math to get to your answers. Okay. Like even if you look at this next one, if you label it S square root of 2, what is that X side going to be? What is this going to end up equaling? Good, 5 square root of 2. Okay, that's like that real basic pattern that we talked about. Okay, now let's take a look at this last one here. So remember, these would still be S, and this is your S square root of 2. Okay, how would I get S solved for on this one? Think about what you did on the first one. How does that same thing apply over here? Okay, I'm going to write this out over here and do what you said. You told me that you needed to divide by the square root of 2. Okay, so they're gone here. Now this time they don't just cancel off, right? But since they're both underneath the square root sign, we can divide that. What is 8 divided by 2? Good, it's a 4. Now that's still underneath the square root. And what is the square root of 4? Good, just 2. So what are your side lengths here? Good, 2 and 2. Good. Okay, let's do another one. These ones are going to start to get a little more challenging down here. Again, I would maybe start by labeling. Okay, so if I look at this one, this is my S side, this is my S, this is my S square root of 2. Okay, now they are giving us the legs, but instead of it just being like a number, like it's not just 4 that we could just plug in and say 4 square root of 2. The whole S side here for this one is 4 square root of 2. But this is still your S, so this whole thing, you're going to have to plug into your S up here and take it times another square root of 2. So it's going to look like this. 4 square root of 2 times a square root of 2. Okay, because we're just plugging it in for the S in order to help me solve for that hypotenuse. Now let's think through what happens here. If they're underneath the square root sign, Okay, remember that we can put them together. So what's 2 times 2? Good, 4. That's still underneath the square root sign. What is the square root of 4? Good, it's a 2, and you have to take that times the 4 that was already sitting out front. So what do you get for an answer here? Good, 8. And so that would be your x. That x side would be 8. So a little bit different in that it wasn't just a number and we were just popping it into the pattern. We were still just plugging a side into our pattern here, but the pattern isn't going to just give me the answer right away. I still had to do a little bit more math in order to get to that final answer there. Okay, let's go on to the next one here. For this next one, I need you guys to make a quick change. So instead of this being 8 square root of 6, I want you to just change it to 8 centimeters. And we're going to do the same thing over here while we're at it. We're going to cross off this 6 square root of 8, and we're just going to make it 6 centimeters. Okay, we're going to do the first one together, and then I'm going to give you guys time to do that last one and see if you can kind of figure it out. So I'm going to start by labeling my sides. So here's my S, and here's my S square root of 2 side. So I said that this side was 8, so I'm going to go ahead and say my S square root of 2 is equal to 8. All right, let's figure out how we would solve for S. How would you guys get that letter S down here in this equation that I wrote by itself? Okay, divide by the square root of 2. Good. Now, in this case, I can't take 8 divided by the 2. Why not? Right, because the 8's not underneath the square root sign. So in like the very beginning of this unit, we talked about how we would simplify radicals. And if you remember, I talked to you guys about how you cannot leave something with a square root in the denominator, right? We said that that's like considered bad form in math. So we need to get that square root out. Do you guys remember how to do that? How do we get that square root out of the denominator? So we had to do something called rationalize the denominator. And that's when you multiply by whatever's causing the problem. So the square root of 2 is the issue here. So you're going to multiply the top by a square root of 2, and you're going to multiply the bottom by a square root of 2. Now, when we do this, on the top, you can't put these together. Like they can't become 16. So it's just going to have to say 8 square root of 2. Okay, but what happens on the bottom? When you take a square root times a square root, what happens there? Yeah, the number just comes out. Okay, so it's just a 2. Now, before we say, okay, we're done, is there any reducing that we can do? Yeah, this 2 can go into this 8. So this becomes a 1, and this 8 becomes a 4. So my final answer here for S is going to be 4 square root of 2, and those are going to be my x's. So this is going to be 4 square root of 2, and this is going to be 4 square root of 2. Okay? A little more complicated as far as like you had to do some more work in order to get your variable by itself there. Okay, now the last one is very similar to this, so I want to let you guys take a couple minutes here and go ahead and do that one on your own. Okay, so if you started this one out, you would have labeled these sides as your S. You would have said this is S square root of 2. We would do the same process that we did on the other one. We would divide by the square root of 2. So we have S equals 6 over the square root of 2. But again, you can't leave it there. So you have to multiply by the square root of 2 on the top and on the bottom. And so this becomes 6 square root of 2 over 2, which reduced to what? Yeah, 3. So these sides are 3 square root of 2. Now, really quick, can any of you maybe make like a quick generalization on these two problems? Like, is there something that you noticed happened? Is there like a pattern maybe here that we're seeing? Okay, so you saw that in this case, if the hypotenuse was 8, that one of the legs was half of 8, and then it had a square root next to it, right? Yeah, and then the same thing happened over here. We had 6, and then the leg was half of 6, which is 3, and then the square root of 2. Good. So some of these problems that you're going to see, while they may not have the exact same pattern as what we began with, some of them start to behave the same way when they're giving you a specific number for the hypotenuse or for one of the legs. So you may even start to discover some other relationships that start to show up in these triangles, and that's going to happen over and over and over again. So if you start to see those kind of things, feel free to use it because it really can help make some of those problems go a little bit faster. Okay? Anyone have questions on the 45, 45, 90 triangle?